Dear friends, welcome to Bond with RK Chemistry YouTube channel. In this video, I am going to explain the previous year questions in SCU PG entrance examination in chemistry from solid state. In 2009, we have 3 questions, 2018 1 question, 2017 1 question, 2016 1 question, 2015 2 questions, 2014 3 questions, 2013 2 questions, 2012 1 question, 2011 1 question, and 2010 2 questions. In this lesson, we have at least one question in SCU PG entrance examination, sometimes 2 questions and also 3 questions. Let us take the questions. Atoms having radius 1.50 angstroms are arranged in a simple cubic lattice. Radius of the largest atom that can be placed at the body center of the cubic cell without affecting the unit cell size is. Okay, let us take the unit cell, cubic unit cell. This is a cubic unit cell. At the corners of unit cell, you have small atoms. These are small atoms at the corners. At the center of the body, you have large atoms. Here, what is the radius? Radius of small one, r is equal to 1.50 angstroms, and this is the edge length. Here, edge length A is equal to 2r is equal to 1.50 into 2, so is equal to 3.0 angstroms. And what is the relation between this diagonal? It's a body diagonal. This is the D. The D is equal to root 3 into A. This is A is the edge length. So D is equal to root 3 into 3. It's a 3 root 3. 3 root 3. Then along the body diagonal, you can find small atom and a large atom and small atom. Okay, this is the D. This is the length of D. Here D is equal to radius of small atom plus, and let us take the radius of large one is capital R. It is the diameter of larger one, so 2r plus radius of small one, small r. So this one is equal to 2r plus 2r. So D is equal to 2r plus 2r is equal to 3 root 3. Here 2r is 1.50 angstroms, 1.50 into 2. So 2r is equal to 3 root 3 minus 3. So it will be equal to root 3 minus 1. So we know the values of root 3, 1.732. So this one is equal to 1.732 minus 1. So it will be equal to 3 into 0.732. Here you have to calculate what is the radius of the largest atom. You have to calculate r. So r is equal to 3 by 2 into 0.732. You will get around 1.10 angstroms. So B is the correct option. Fraction of the unit cell occupied by atoms packed in an FCC lattice is. In simple cubic, we have primitive, that is simple cubic, and body centered cubic, and face centered cubic. Then what is the relation between edge length and the radius? R is equal to A by 2. In this case, R is equal to root 3 by 4A, and in this case R is equal to 1 by 2 root 2 A. And what is the packing fraction? Packing fraction in simple cube, packing fraction is pi by 6. In body center cubic, root 3 by 8 pi. In face centered cubic, root 2 pi by 6. The pi by 6 is a simple cubic. When you multiply with root 2, you will get packing fraction of face centered. Okay, this one is around 52 or 0.52 fraction, and this one is 0.68, and this one is 0.74. This is the packing fraction in terms of numbers. So what is the correct option? This one, root 3 pi by 8, this is BCC packing fraction. This is simple cubic, and this one is FCC. So D is the correct option. The Miller planes that are mutually perpendicular are. Okay, let us take the two Miller planes, H1, K1, L1, and H2, K2, L2. Here the angle between the two planes, cos pi, is equal to H1, H2 plus K1, K2 plus L1, L2 divided by root over H1 square plus K1 square plus L1 square and H2 square, K2 square, L2 square. Okay, for perpendicular, pi should be 90 degrees. When cos pi is equal to 90, cos 90 degrees, we know that it's a 0. When cos 90 is equal to 0, when H1, H2, K1, K2, L1, L2. Suppose when H1, H2, K1, K2, L1, L2 is equal to 0, then this whole term will be equal to 0. Then cos pi is equal to 0, then pi is equal to 90 degrees, and the two planes will be perpendicular to each other. For this, you have to multiply first term with first term. 1 into 0, 0, 0 into 2, 0, and 0 into 0, 0, so 0. So these two planes will be perpendicular. Let us check other options. 2 into 4, 8. So this is not is equal to 0. So these are not perpendicular. 2 into 1. This one also not is equal to 0. 2 into 1, 0 into 1, and 0 into 0. You will get 2. In this case also you will get 1 into 1. You will get 1. This one is not is equal to 0. So the first 1, 0, 0 and 0, 2, 0 planes are perpendicular. When copper K alpha X-ray with wavelength lambda is equal to 1.54 angstrom is used, the diffraction from the 320 plane of a crystal occurs at 2 theta is equal to 45.6 degrees. If molybdenum K alpha X-ray with lambda is equal to 0.71 angstrom is used, diffraction from the 320 plane will be found at 2 theta is equal to. Okay, we know the Bragg's equation. Bragg's equation, n lambda is equal to 2d sin theta. Here n is the order, lambda is the wavelength of X-ray, and d is the interplanar distance, and theta is the diffraction angle. In this question, lambda is given, lambda of copper is given, and lambda of molybdenum is given, and 2 theta of copper is given, and 2 theta of molybdenum you have to find out. Here d is same, you are taking same plane, 320 plane and 320 plane. So the interplanar distance is same. So if you take lambda 1 by lambda 2, and let us take n is equal to 1 for for the two conditions. Then lambda 1 by lambda 2 is equal to, since d is constant, it will be equal to sine theta 1 by sine theta 2. Lambda 1 is given 1.54 divided by lambda 2 0.71 is equal to sine theta 1. This is a theta 1, let us take. 2 theta is equal to 45.6 degrees. So theta is equal to 45.6 degrees by 2. So it will be equal to 22.8 degrees. So theta 1 is equal to 22.8 degrees. So sine 22.8 degrees. You have to find out sine theta 2. So that implies sine theta 2 is equal to 1 sine 22.8 degrees into 0.71 divided by 1.54. Okay, when you simplify, you will get sine theta 2 is equal to, you will get 0.1786. Then theta 2 is equal to sine inverse 0.1786. So theta 2 is equal to, nearly you will get 10.3 degrees. Then 2 theta 2, you have to find out 2 theta value. It will be equal to 20.6 degrees. So the 100 X-ray diffraction peak of a cubic crystal occurs at theta is equal to 19.50 degrees. The 111 diffraction peak will be observed at. Again, n lambda is equal to 2d sine theta. This is the Bragg's equation. Here, two different planes are given and the same lambda. Lambda is constant, but there is a change in d and theta. Then what is the relation? Sine theta is equal to n lambda by 2d. So sine theta 1 by sine theta 2 is equal to d2 by d1. Then how can you calculate d values, interplanar distance, from HKL values? You know that d is equal to 1 by d square is equal to h square by a square, k square by b square, and L square by C square. For cubic system, A is equal to B is equal to C. All the lengths are equal. So 1 by d square is equal to, for cubic system, h square plus k square plus L square divided by a square. Then d square is equal to a square by h square k square plus L square, and d is equal to a by root over h square k square L square. Okay, let us calculate d1 and d2. Okay, d1 is equal to a square, a by root over h square k square L square. These are h, k, L values. So root over 1 square 1, 0 square 0, 0 square 0. So you will get a simply. d2, what is the interplanar distance for this plane? 1 1 1. So this one is equal to 1 square plus 1 square plus 1. So a by root 3. So d2 a by root 3 and d1 is a. So what is the ratio you will get? A by root 3 by a, you will get 1 by root 3. Sin theta 1 by sin theta 2. Sin theta 1 is given 19.50 degrees. Sin theta 1 is given. So sin 19.50 degrees by sin theta 2 is equal to 1 by root 3. Then what is the sin theta 2 value? Let us Let us do cross multiplication. You will get sine theta 2 is equal to root 3 sine 19.50 degrees. Here sine 19.50 degrees, you will get around 1 by 3. So sine theta 2 is equal to, you will get 0.577, then theta 2 is equal to around 35.239. You have to take sine inverse of this one. When you take sine inverse of 0.577, you will get 35.239 degrees. So it's around 35.32 degrees. X-ray diffraction from a cubic lattice shows the 110 peak at theta is equal to 20 degree. What will be the angle for 111 peak? Here we know that sine theta 1 by sine theta 2 is equal to d2 by d1 from Bragg's equation. N lambda is equal to 2d sine theta 1 by sine theta 2 is equal to d2 by d1. Then what is d and what is d1 and what is d2? Okay, this is the interplanar distance of this plane and this plane you have to calculate. 110, what is the d? d1 is equal to, it will be equal to a by root 1 square plus 1 square plus 0. It will be a by root 2. And what is d2? d2 is equal to this one 111. So a by root 1 plus 1 square plus 1 square plus 1, it will be root 3. So if you take sine theta 1 by sine theta 2 is equal to a by root 3 divided by a by root 2, you will get root 2 by root 3. You have to calculate sine theta 2. So sine theta 2 is equal to, when you do cross multiplication, root 2 sine theta 2 is equal to root 3 sine theta 1. We have to divide with root 2. So finally you will get after simplification root 3 by root 2. What is the theta 1 value? Sine 20 degrees centigrade. When you substitute sine 20 degree and root 3 by root 2 value, you will get around 0.4188. Then theta 2 is equal to sine inverse 0.4188. Okay, for this calculation you have to use the scientific calculator. This sine inverse 0.4188 is nearly 24.8 degrees. So this is a correct option. In the X-ray diffraction pattern of an FCC crystal, the peak due to the 111 plane occurs at 2 theta is equal to 24. The peak due to the 222 plane will be observed at 2 theta is equal to, in this case also, sine theta 1 by sine theta 2 is equal to d2 by d1. Here you have to calculate d1 and d2 values. What is the d1? 111 plane related. d1 is equal to a by root 1 square plus 1 square plus 1 square. It will be a by root 3. And d2 is equal to a by root 2 square plus 2 square plus 2 square. So you will get root 12. Then you have to find out sine theta 2 value. Here theta 1 is given. 2 theta is equal to 24. So theta 1 is equal to 12 degrees. You have to find out theta 2. Then what is the sine theta 2 is equal to? Sine theta 2 is equal to d1 sine theta 1 by d2. So d1 by d2, what is the d1? A by root 3 and a by root 12. This one is a by root 3 divided by a by root 12 into sine theta 1. Sine theta 1 is 12 degrees. So this one is equal to, and 3/4. So this one is equal to root 4 sine 12 degrees. So 2 sine 12 degrees. Here the sine 12 degrees is 2 into 0.2079. So it will be equal to 0.4158. If you take sine inverse of theta 2 is equal to sine inverse of 0.4158. Sine theta 2 is equal to 0.4158. Then theta 2 is equal to sine inverse 0.4158. So sine inverse 0.4158 value is around 24.56 degrees. You have to find out 2 theta value. Then 2 theta 2 is equal to, it will be double 24.56 degrees into 2. You will get around 49.2 degrees. So D is the correct option. The Miller indices of the face having intercept 1 by 2a, 2b and infinity c, where a comma b comma c are the unit cell axes. What are the Miller indices? Here the a comma b comma c are given and the intercepts of a comma b comma c are given. These are called as V's indices. A, b, c. What are the intercepts? 1 by 2, 2 and infinity. These are called as V's indices. To convert V's indices into Miller indices, first you have to take reciprocal of V's indices. Reciprocal means reverse of this fraction. It will be 2 by 1 and 1 by 2 and 1 by infinity. So you will get 2, 1 by 2 and 1 by infinity is 0. First you have to take reciprocal, and after that you have to multiply with some factor to get minimum numbers, to get least numbers. You have to multiply with some number in such a way that the number should be minimum. So when you multiply with 2, you will get 4, and this one is 1 and this one is 0. Then you will get Miller indices. How can you convert V's indices into Miller indices? First you have to take the reciprocal of V's indices, and after that you have to multiply with the LCM of these numbers, or you have to multiply with a number which converts the fractions into least numbers. So here when you multiply with 2, you will get the least numbers. The fractions will be converted into numbers and these numbers are least numbers. So what are the Miller indices? 4, 1, 0 are the Miller indices for 1 by 2a, 2b and infinity c. The perovskite structure has a formula AbO3. The A cations form a primitive cubic closed packing with the oxide ions occupying the centers of the faces and the B cations at the body center. The total number of ions A, B, O in the unit cell are respectively. Okay, what are the positions of A, B and O? Here A forms a primitive cubic, means all the A are at corners. All the A's are at corners, and B cations at the body center. This is body center, and oxide ions occupying the centers of the face, center of face. Okay, here how many corners are there? 8 corners are there, and each corner contributes 1 by 8, so it will be 1. So how many A's will be there? Only 1 A per unit cell. And body center, you have one body center and its contribution is 1, so 1. And center of face, how many faces are there? You have 6 faces, and if the particle or atom at face center, it will be shared by 2 faces. So the contribution is 1 by 2, so it will be equal to 3. Then how many A's are there? 1, and B 1, and oxygen 3. So 1, 1, 3 is the correct option. In X-ray diffraction experiment, X-rays of 0.1 nanometer reflected from a crystal surface at 30 degrees. The interplane distance would be, what is the interplane distance? Bragg's equation, according to Bragg's equation, n lambda is equal to 2d sine theta. Here you have to find out d value. For n is equal to 1, lambda is equal to 2d sine theta. For first order, lambda is equal to 2d sine theta, and d is equal to lambda by 2 sine theta. Lambda is given 0.1 nanometers, 0.1 divided by 2 into sine theta. Theta 30 degrees. So 0.1 divided by 2 into sine 30, 1 by 2. So 1 by 2, 2 cancel. So you will get 0.1 nanometers. So this is a correct option. The interplanar distance between 100 planes of a simple cubic is 0.3 nanometer. The distance between 222 planes would be, okay, interplanar distance D100 plane is equal to, for cubic system, it will be equal to A by root over h square plus k square plus L square, 1 square plus 0 square plus 0 square. So it will be A. Here D100 is given as 0.3, means D100 is equal to A is equal to 0.3 nanometers. For 122 plane, what is the interplanar distance? What is the distance? D122 is equal to A by root h square plus k square plus L square. This is for simple cubic. So 1 square, 2 square 4, 2 square 4. So you will get A by root 9. So it will be A by 3. And A is 0.3 nanometers. So 0.3 by 3, it will be equal to 0.1 nanometers. The 100 X-ray diffraction peak of a cubic crystal occurs at theta is equal to 19.50 degrees. At which of the following angles will be the 100 diffraction peak appears if the unit cell length is doubled? Previously the unit cell length is, let us take A, and after doubling the unit cell length will be 2A. From Bragg's equation, n lambda is equal to 2d sine theta, and d sine theta 1 by sine theta 2 is equal to d2 by d1. Here d is equal to, for cubic system, A by root over h square plus k square plus L square. So for d1 is equal to A by root h square k square L square value will be 1. 1 plus 0 plus 0, it will be A. For d2, the unit cell length is 2A and the plane is 100. So you will get 2A. You have to find out sine theta 2. What is the sine theta 2 value? Sine theta 2 is equal to d1 by d2 sine theta 1. d1 is A, d2 is 2A. So d1 by d2 will be 1 by 2 sine theta 1 19.50 degrees. When you simplify this equation, you will get around 0.166904. This is the sine theta 2, and theta 2 is equal to sine inverse of 0.166904. You will get around 9.61 degrees. So C is the correct option. Of the number of tetrahedral voids to the octahedral voids in cubic closed packing arrangement is. Suppose if you take any system, any closed packing system, there are some octahedral voids and tetrahedral voids. The number of octahedral voids is equal to n. Here n is the number of particles per unit cell, and the number of tetrahedral voids is double to the number of octahedral voids. It will be 2n. Suppose if you take FCC or CCP, in this case n is equal to 4. N is equal to 4. So the number of octahedral voids 4 and tetrahedral voids 8. Suppose if you take HCP, hexagonal closed packing, you have n is equal to 6. The number of particles per unit cell 6. So the octahedral void 6 and the tetrahedral void 12. If you take any closed packing, the number of tetrahedral voids are double to the octahedral voids. So the ratio will be 2:1. The density of an elemental silver having FCC lattice with unit cell length of 4.086 angstroms is. Okay, atomic weight is given. What is density? Density is ratio between mass and volume. Okay, here mass of unit cell, you can take mass of unit cell and the volume of unit cell. Okay, mass of unit cell, it is due to the particles which are in unit cell. Then suppose if the unit cell has Z number of particles and each particle has a mass m, let us take m, and the volume of unit cell, if the edge length is a, volume of unit cell will be a cube. And the mass of each particle can be written as Z capital M by Avogadro number a cube. Here small m, it is the mass of individual particle. It is the mass of 1 mole of particles divided by Avogadro number. So this is the equation. D is equal to Zm n a cube. Here Z is the number of particles per unit cell, m is the molar mass of that element, and n is the Avogadro number, and a is Avogadro number, a is edge length. Here FCC for phase centered cubic, the Z is equal to 4, the number of particles 4. So 4 into what is the molar, what is the mass here? 108, atomic weight is 108. So 108 divided by Avogadro number 6.023 into 10 to the power of 23, and A is given. A is equal to 4.086 angstroms. Here the density is gram per centimeter cube, so you have to convert into centimeters. 4.086 into 10 to the power of minus 8 centimeters. So this one is equal to 4.086 into 10 to the power of minus 8 whole cube. After simplification, you will get around 10.5 gram per cc. So B is the correct option. X-ray diffraction study of a crystal with a simple cubic lattice structure shows diffraction from the 110 plane appearing at the Bragg's angle theta is equal to 20 degrees. The angle at which the diffraction from the theta 220 plane will appear is, again, n lambda is equal to 2d sin theta, Bragg's equation, and sin theta 1 by sin theta 2 is equal to d2 by d1. You have to find out sin theta 2. So sin theta 2 is equal to d1 sin theta 1 by d2. Then what is the d? For simple cubic, d is equal to a by root over h square k square l square. So d1 is equal to This is D1, 1, 1, 0 plane D1 and 2, 2, 0 plane D2. So 1, 1, 0, it will be root over 1 plus 1 plus 0, 1 square plus 1 square plus 0 square, it will be a by root 2. And what is D2? D2 is equal to a by root over 2 square plus 2 square plus 0, 4 plus 4 plus 0, it will be a by root 8. Then d1 by d2 will be equal to a by root 2 divided by a by root 8 sine theta 1. Here theta 1 is 20 degrees. So you will get to root 2, root 8, it will be root 4. You will get 2 sine 20 degrees. This is sine theta 2. Sine theta 2 is equal to 2 into sine 20 degrees. 2 into sine 20 degrees will be equal to 0.68404. 0.68404. Theta 2 is equal to sine inverse of 0.68404. So finally you will get around 43 degrees. Theta 2 is equal to 43 degrees. Among the following, which one is a crystallographic point defect? Okay, we can classify defects into point defects is a zero dimensional defect, line defect one dimensional defect, surface defects or interfacial defects it's a two dimensional defect, and volume defect it's a three dimensional defect. In point defects we have vacancy point defect, Schottky, Frenkel, substitutional, color centers, polarons and excitons. Okay, these are point defects. Line defects you have edge dislocation, screw dislocation. In surface defection we have grain boundaries, tilt, twist and stacking faults. In volume defects we have inclusions and voids or cracks. So here edge dislocation it's one dimensional line defect. Screw dislocation it is also one dimensional line defect. Schottky it's a point defect. Schottky and Frenkel these are point defects. And a stacking fault it's a two dimensional surface defect. So what is the point defect? Which among the following is point defect? Schottky defect is point defect. Potassium crystallizes in a body-centered cubic lattice with A is equal to 5.20 angstroms. The distance in angstroms between nearest neighbors, the number of nearest neighbors, and the number of potassium atoms in the unit cell are respectively. Okay, body-centered cubic. Let us take the body-centered cubic structure. In body-centered cubic, the potassium atoms occupy at corners of the cube and also center of the body. Here, the number of potassium atoms in the unit cell. Here at corners you have 8. The contribution at corners is 1 by 8. So it will be 1. At body center you have 1. So 1 into 1 is equal to 1. So you have 2 potassium atoms per unit cell. 2 potassium atoms. And what is the number of nearest neighbors? It's the coordination number of potassium. If you take body centered potassium, it is coordinated with 8 potassium at corners. So the nearest neighbors are 8. And you have to calculate distance in angstroms between nearest neighbors. What is the distance? Okay, this is the distance between nearest neighbors. Here nearest neighbors distance is 2r is equal to, we know the relation between r and edge length. This is the edge length. R is equal to root 3 by 4a. What is the nearest distance? This is the nearest distance. Nearest distance is equal to radius of this one and radius of this one. It's a 2r. 2r is equal to root 3 by 4a into 2. So this one is equal to root 3 by 2a. So the nearest distance is equal to root 3 by 2 into what is the a value? 5.20 angstroms. So when you calculate, when you simplify, you will get around 4.50 angstroms. So what is the correct option? 4.50, 8 and 2. Thank you very much.